computers. So far, we have looked at elements of a computing system. We also looked at algorithms. In this video, we're going to take a look at flowcharts and pseudocodes. And we're going to, of course, to learn how to convert from pseudocode to flowchart and vice versa. So we're going to start with a flowchart. We're going to learn how to read a flowchart. So the basic steps are: we first have to start at the oval, which of course represents the starting of the flowchart, and there'll be it will be written inside the word start. Then from there you go to follow the arrow from the oval. You just follow the arrow that comes from the oval. Then you go to the next point, whatever it is, but when you reach the input where there is a parallelogram, you identify the input. Next, of course, when you reach a process or a decision, which is of course which are of course represented by a rectangle and a diamond respectively, you perform necessary calculations or comparisons. So on a process or rectangle, you have to do the calculation so that you know the output where, if that is required of you. Then on a decision or a diamond, you have to do necessary comparison. For example, you have to ask yourself if the input data or the input value is valid or not. Then of course you end at the oval, which is written stop. So this is an example of a flowchart. Let's try to read it. So of course here it's start, that's why it's starting. Then we follow the arrow, it takes us to input R. So here we expect someone to enter a number which we're going to call R. It can be 5, it can be 10, but whatever it is in our computer, it will be called R. Then next step, it's a process because it's a rectangle, so we're going to do calculations. So we're going to say area is equal to pi times R times R. So this is the way to write pi R squared. If you write pi R squared, the computer won't recognize this. So the best way to write is to use computer symbols, which we learned in the previous video. So pi and R, you put an asterisk which represents multiplication or times. Then also the way to write R squared, you write R asterisk R, which is of course R times R. With that being said, when you perform the necessary calculations here, you go to the next step, which is of course print A, where the results are shown to the user. Then of course you go to the last stage where the process ends, and of course it's the oval that represents stop. So there's a question that I once saw. It was saying they had given a flowchart like this. Then the question was, what will be the output? What will be the output if the user enters 10? So what will be the output if the user enters 10? So for you to understand that, you have to understand the flowchart. You have to understand what result it will give out, and of course what process is going to be carried out, and what is it we're expecting from the user. So if the user enters 10, then of course our error, it means it's 10. Then that 10, which is our error, is going to be taken to the process. So it will be the computer is going to take pi, and it will multiply by the 10, and also multiply by the 10. So if you multiply pi, which is of course a number 3.14, it will be 3.14 times 10 times 10, which is going to be 314 as your result. So on print A, the computer or the calculator or your smartphone will show 314. So the answer was supposed to be 314 if the question was posed in the way I'd described. Let's try to read this other one. So the previous one only contained one form of control structure, which is a sequential. A process was just going down, down, down in a sequence. But this one this one has two additional control structures. The first is sequential, where we just go. Then there's also a branching here, the diamond, where we can go this side or this side, depending on what happens here. Then we also have a loop or a repeat, where we go back and come here, we move in a circle kind of. So let's try to read this. So start, the program starts, input R, so we expect the user to enter any number. Then from there we go to the diamond where a decision has to be made. So in the diamond here, we ask ourselves, the number that has been entered, is it less than 0? If that number is less than 0, then there are two directions we can get. We can go to, of course, there's this when it's no, and here when it's yes. So if that number is less than 0, which means we go to the yes, it's less than 0, then we display or we show to the user that there is a mistake. So we say error, R must be greater than 0. Then we ask the user to enter data again, to input another R. So when the user inputs another R, again we come here, we do the comparison. If R is less than 0, we do the same, just like that, till the user enters a valid R. A valid R is R which is greater than 0, greater or equal to 0. So if the user enters R which is greater or equal to 0, then our program here, if it tries to compare, is R less than 0? Of course no, since it's greater or equal to. So the program will continue sequentially. So it will go to this next step, where again it will get pi multiplied by the R that the user had entered and multiplied by the same R. Then the result will be given out to the user as print A, and the process is going to stop. So this is how to read the flowchart. Now we move to pseudocodes. So the steps of a flowchart, if written word by word, are what makes a pseudocode. So pseudocode, the word pseudo means false. So pseudocode is false code. So it's like something that mimics the actual code, but it's not the code. The code of a computer are specific, depends. They are what are called computer languages, which of course differ from platform to platform. For example, the computer language that I use to make website are different from the computer languages that I use to make for example some desktop apps or applications on your laptop. So the actual code depends on the platform and other issues that have to do with computer science or computer engineering. But here it's mathematics, so we're going to write words that mimic computer codes. So those words are just like the way the flowchart is, but we use words to represent the flowchart. Okay, so the key point is other than these other normal things which you can write in words, for example, input or enter this, decisions are represented by what is called an if statement. So an if statement is the one that corresponds to the diamond on a flowchart where a decision has to be made. So an example of an if statement is this: if R is less than 0, then display R must be greater than 0, else display A equals pi times R times R, or else A okay, let me just read this again. So if R is less than 0, then display error, R must be greater than 0, else display A equals pi times R times R. So what this means is a decision has to be made here in the if statement. So if R is less than 0, then do this. If of course R is less than 0, but if R is not less than 0, then we do something else. So these three words, if, then, else, they go together. Okay, if, then, else. So if you write your condition here, then something has to be done. If the condition is not satisfied, something else has to be done. So it always goes if, then, else. So for example, if we have this part of a flowchart where decision has to be made, is R less than 0? Yes, do this. No, do this. So using pseudocode, we can write this as if r is less than 0, then, so is r less than 0 becomes if r is less than 0, then of course yes goes with then. Okay, so is r less than 0? Yes. If r less than 0, then do this. Then what has to be done is this. So we can write this in the next line: display error, r must be greater than 0. And I recommend you to put in quotation marks what has to be displayed. So all this error, r must be greater than 0, you can put in a single quotation mark just to show that it is something that should be together. And display is just an instruction that says display everything in the quotation marks. So so what if r is greater than 0? So that's where else comes in. Else, which is of course the no part, do this, then we can show display a is equal to pi times r times r. So there is one mistake here. For those who have eyes, maybe you can see here is display, but here is process. So here we're supposed to use a shape for display, which is this one. Okay, hope you are able to tell. With that being said, so we have got a question here. Write a pseudocode to find the area of a circle with radius r and pi, and draw a flowchart for it. So they want pseudocode to find the area of a circle with radius r and pi, and draw a flowchart for it. Of course, we have seen examples of this, but let's see how we the thinking behind it. So what do we need? We need to know the area of a circle, which is given by pi r squared. So pi r squared, what number do we need for us to calculate that? Pi is just a number, 3.14, it never changes. But r is the number that depends on a circle. So r must be entered. Therefore, r is the input, or what has to be entered. So I've identified the input, which is the most important step, identifying the input, and of course the calculation that's going to be done in the process. So now there is also an issue of validity. The number that is being entered should be valid. If it's not valid, it will, if it's a calculator, it will show you syntax error or math error. So when it's like that, it means there are some things that have been entered which are not valid. So we should care about validity. Radius is length. Is there a circle with negative radius? No. So that's the issue of validity. So we should be we should be able to create a program that is able to validate the value of r, to test if r makes sense or not before it can start computing. Otherwise, our program is going to crash, or it's going to display syntax error or math error. So we don't want that. If of course the user enters a wrong number or a negative number, we should tell the user that this number is wrong. There is an error, this number is wrong. Not a situation where when we put our r into our process or into our calculation, it gives us funny answers. With that being said, how do we start? Of course, we start with the start. So start. Next, we ask the user to enter r, input r. So when this r has been entered, we have to check if it is valid. So it's a decision. A decision is if statement. So we're going to use an if statement. So be like, if r is less than 0, then, so there's a reason why I have written like this, because I want to do something here, but it's okay to write then here, or here it's okay, but I like it, write it in the same line as if. If r is less than 0, then what should be done? If it's less than 0, we tell the user to do something. So we're going to tell the user that the r value that has been entered is wrong. Enter r's that are greater than 0. So we're going to display error, r must be greater than 0. Enter r again. Okay, with that being done, we're expecting the user to enter r. So the user will enter r again to be validated, and if it's again wrong, this is going to happen. But what if the opposite happens? What if the user had entered the correct value? So we go to step 4, where we go to the next step, the calculation, since r is now greater than 0. So remember how it goes: if, then, else. So else is the one that gives us the ability to continue with the steps. So else area pi times r times r. So this is a process where we have gotten r, we multiply it by itself and by pi. Okay, then after that, of course, we can show the user, we can use display a or print a or output a. You can use all those words, then we can stop the process. So the way I've done my pseudocode, I've numbered. So if you want, you can be numbering. I like it numbering line by line, but of course it depends on yourself, the way you want to write it. Some don't number. If you want, you can number, but numbering, it's a good practice. So so this is the pseudocode we're from writing. So if we've been asked to actually now we need to come up with a flowchart for this pseudocode. So the flowchart is so you forgive me about this. So we start here. So start is start, enter r, it's input parallelogram. So input r. So if r is less than 0, we're talking about decision. So we need the diamond, and inside we are going to write is r less than 0. So is r less than 0. So there are two outputs. If r is less than 0, we're going to do this. Is if r is greater than 0, we're going to continue. So is r less than 0, then display error, r must be greater than 0. Enter again. So we go to this direction where we display error, r must be greater than 0. Of course, enter again. It's just that I ran out of space. Then of course, else we continue. So of course we have to write yes there to show that yes, r is less than 0. Then for else, of course, it's no. By the way, anyway, we'll come to this part. For now, let's skip it. So let's continue with our steps. So if it's no, of course it's else, we do this. So this is the process that has happened here. Else this process should happen, this calculation should happen. So this is the calculation that has happened. Then from there we print a and we stop the program. Okay, so everything has been explained. The decision has been made here. If r is less than 0, yes, do this. No, which is else, do this. Print a, stop. Now this part where it's going back. Okay, so this is not part of the pseudocode here. It's something that I included to emphasize something. So our pseudocode ends here on the yes part. So but normally, depending on exact what's happening, the type of machine you're using, it's better you ask the user to enter r again. So when you do this on the pseudocode, after display error, r must be greater than 0, enter r again, the next step should be input r before the else statement. So 5 should be input r, because after here it goes to input r. Okay, then from there you go to else, which is going to be 6, then print 7, then stop. Okay, so hope you have followed the explanation here on the implication of this. So if I can just emphasize it again. So after display, we want to tell the user to enter r again. So in our flowchart, in our pseudocode here, when you say display, the next should be input r. Then after input r, we stop. Okay, then we go to else here when it continues. Okay, why do we stop after input r? It's because our program has fully looped. We were here, then it has gone back to here. We have already written for what happens after here, so there's no need to write it. So when you go to input r, it means we have gone back to the program. Our computer will know what to do when r has been entered, and that is it to go to the next step, and it will keep on looping if the user is not entering correct data. But if the user enters correct data, then it will continue to the process, and then to print out, and then finally it will stop. So this is all about for. So there's another question here. The following flowchart shows the steps in calculating the volume of a solid given the base area A and height H. Write the pseudocode for the flowchart. So they have given us a flowchart. They want So this is the flowchart. So let's read it, then we'll write the corresponding pseudocode. So start, enter A. Is A less than 0? Yes. Display error, A must be positive. So this is the opposite of what we are from looking for. We are from discussing, because this one doesn't take the the program back to enter A. So it will just tell the the user that there is a mistake, but it won't advise the user to enter again. It's up to the user to start the program from here. Okay, so if A is greater than 0, it will continue to enter H. Again, H it has to validate. So to find out if H is valid, is H less than 0? If H is less than 0, it will show a mistake. But if H is greater than 0, it will continue to calculating volume by volume is equal to area times H. Then it will display the volume and it will stop. So now let's write the corresponding. So of course, so we're going to start, then input A, then A has to be verified. So if A is less than 0, then show the mistake, display error, A must be positive. Otherwise, if A is greater than 0, you continue. So we go to else, we continue. We ask the user to enter H again. If the user enters H again, we have to validate. So to validate again, we're going to use an if statement. If H is greater than 0, then again we show the mistake. But if H is actually supposed to be less than 0, not greater than 0. If H is less than 0, then show the mistake. Then after that, you can go to you can continue the step where we go to calculations, else do the calculations. Then after the calculations, we can show the results. Then after showing the results, we can stop. So maybe there are some people who still don't understand the meaning of how A greater than how A less than 0 gives a mistake. So A greater I mean A less than 0 gives a mistake. A less than 0 implies that the number is negative. All numbers that are less than 0 are negatives. So when it comes to area length, we can't have a negative length. Can you move a negative distance? No, you can't. You can move 2 meters, but you can't move negative 2 meters. Okay, so because of that, negatives are not valid here. So usually it's a very good practice to test the validity of the input and show mistakes when mistakes have been made. And if mistakes are not there, then you can just continue with the program.